height as well as what can be on the test in terms of what he was talking about. So first one was climate versus weather. This will be on the test, and he used the analogy of clothes in a closet. So climate is what we expect or trends over a long time. I made the assumption that you guys knew that. You might not have. Weather is what we get. So and here in Nebraska, think about all the different clothes that could be in your closet. That's your climate. But weather is what you're actually wearing today. So those are like daily, hourly periods. He also talked about a stationary versus a non-stationary climate. So stationary means overall not changing, and he showed a model that showed when the energy into the Earth system is equal to the energy out, that's when we have a stationary climate. A non-stationary climate means that there's lots of change, that the past is not the same as the future. One of the things that he mentioned was that we use past climate to figure out things for present day infrastructure and pieces of our society. And so he said that we can't keep going on. Then he talked about anthropogenic changes. We're not going to test that term, but you will hear it a lot. It means humans are responsible. We're not going to test that term, but I thought it was worth mentioning here. Our forcings, though, our anthropogenic forcings will be on our test. So in other words, humans cause changes in greenhouse gases. You know greenhouse gases are a forcing. We change that. We change aerosols. You know aerosols are a forcing because we burn fossil fuels and biomass. We also change our albedo because of land use changes. So if you look at that image, that's some center pivots, and you can see that the ground surface is changing from like green because of photosynthesis to the more brown dormant, and that will change Earth's albedo. Mitigate, that word he used, will not be on the test, but it means solutions, like what we've already talked about, carbon capture. You will have a concept like carbon capture on the exam. So we talked about catching carbon dioxide and holding it in the carbon cycle and how we could do that in oceans or in rocks. But we also talked about changing things like energy efficiency. So keep thinking about that as you're going through your turbines and as you are thinking about future voting, which is a bigger thing to focus on. Is it stuff like carbon capture, or is it something more like energy efficiency? Another piece that I thought was worth revisiting was this image that he showed. So he showed these two graphs, one on the left and one on the right. The one on the left are computer models based off of historical and current data. And what we can tell from that information is that our models are good. Our computer models are accurate and precise because they all match. So they can both reconstruct historical data as well as match current observations, which means they're accurate. And so then he switched over to the right image, and so what happens is when you take that model and you say, okay, is it human caused? Is it anthropogenic forcings? You take out the humans, and that's the right image, and what we see is the blue line there towards the bottom, so here right in this general area. And so your natural forcings, this is where our climate should be, but with humans in there, this is where we are. And so because we can see that disparity between those two, that's another reason why we know it's human caused. So now we have several bits of evidence. We have the isotope of carbon, we've got past historical data, we've got rates of change, and we've got computer models. Current trends are due to human introduction of carbon dioxide, and he made no qualms about it. It was humans, but that there was hope. Part of the hope he gave us was here. And these three lines are projections of the current trends, and the current line here based off of those computer models. And so what we see is if we keep going as we're going with no changes whatsoever, this is where we're going to end up with about 8 to 9 degrees of temperature change. And this line actually goes down as low as 5, so 5 to call it 9. But if we start making other changes, we could get, this is fairly aggressive, this one's not as much, but we could get closer to what the IPCC recommended for rates of change. And so that takes us into sustainability. You're working on your sustainability project. We talked about how that means people, planet, and profit. So for people, it makes your life easier, more pleasant, better quality of life, better relationships. It's something that you're willing to do or purchase or buy or be a part of. The planet means it uses those planet resources effectively, efficiency. It considers both direct and indirect impact on the planet. So direct means, and you're not tested on direct versus indirect, but it's helpful when you're thinking about sustainability. So direct we tend to is easy. Minerals, land, where does it go? Where did it come from? But indirect are things that we don't necessarily remember about. So it's the energy during transport. It's the maintenance of the roads during that transport. It's the person's car who went to the factory to produce whatever product it was. Those are the indirect impacts. And so each purchase that you make, each thing that you do has kind of this embodiment of energy that we tend to forget about and goes to the back of our minds. And so when we're talking about sustainability, we're trying to keep that not in the back of our mind, but in the front. And so planet part has to consider those parts too. And then profit. Is it affordable? Is it going to save money? Is it going to help our economy, harm our economy? Or is it going to generate profit? So you're tested on only those big three. You don't have to worry about those bearable, equitable, viable, because it can be pieces and parts. But just know we're trying to always hit this nebulous kind of center spot of sustainability. So in that, you're used to thinking about renewable and non-renewable resources. So when we're talking about renewable and non-renewable resources, they're resources that can be replaced over short periods of time. They're clean in general. They don't have produced CO2, or they may even reduce CO2, but oftentimes need infrastructure changes, so they can tend to be a little bit more expensive. And then, of course, chicken and the egg. Do you make the new resource, or do you wait for the demand, or vice versa? Non-renewable resources are ones that we're used to, those fossil fuels, resources that take a long amount of time, and the infrastructure is already in place, but they might produce CO2. So what's that word, infrastructure? It's the know-how, the equipment, and the logistics to make things work. So it's the tankers, the roads, the cars, the pumps, the bits and bobs that make things work. So when we have that infrastructure in place, that chicken and the egg thing is no longer a thing. But when we don't have that in place, that's what can make things a little bit more expensive. So when we're talking about sustainability, infrastructure becomes a bigger deal as well. When we look at our current energy usage here in the United States, what we find is that 89% of our energy comes from non-renewable resources, and only 11% comes from renewable resources. And starting next week, we will talk more about those.